All right, let's go ahead and jump right in. So looking at what's due when for week 3 here. Don't forget you've got a quiz to do by Wednesday. In lab today, I have to do a classroom observation of another instructor, and that happens in the very next hour, so I won't be in lab today. Of course, Jesse will be there. So keep that in mind. I believe the lab should be pretty straightforward. And the video bits you should have watched would help you complete the labs. So there's that. Let's see what else. We have an assignment here in class today. We'll get going on that in just a moment. And then finally, due on Friday night is the first project. Now I haven't talked about it much simply because there's not a lot to the first project. So let me crack that open really quick. Create a number guessing game. The computer is going to randomly select a number between 1 and 10. You ask the user to guess the computer's number. The person's allowed a single guess. And you just say whether or not they guessed right. That's it. Output statement, so there's a random number, we'll look at that in a second. Output statement, what's your guess? Input statement to get the user's number. And then a quick check to see whether or not they guessed correctly. There's extra credit, which I won't go into, but it steps it up if you're feeling up to the coding challenge. But this simple bit is certainly sufficient. So the random number. We've seen the pound include IO stream that we put at the top of files. You have to deal with random numbers, you have to add a couple more. Just add them right before or after the IO stream. This is the code you need. Now keep in mind that that's all comment and that's all comment. So really all that's here is 1, 2, 3 lines of code to generate a random number for the computer. SRAN means to seed the random number generator. Let's see, how much detail do I want to go into this? I'll talk a moment about it. So the computer's incapable of generating truly random numbers. It can't pull from the ether, kind of like we can pull from our head a random number. So there's actually a hard-coded list of random numbers inside the computer. And if you're to look at them, you go, yeah, they look pretty random. The thing is, though, if you ask the user for a random number, let me jump down here for just a moment. That right there, that function call, will asks for a random number from the computer and returns it. And it's some really large number between 0 and 4 billion, something like that. But if I ran my program, and let's just say actually I can go ahead and do this. Why don't I just actually do it? Let me see. I think I want to go somewhere else here. Oops. There we go. All right. So we have the IO stream, and then we have the two that you need here, C standard lib and C time. So I can actually, as I said, that just returns a number, a random number. So I can actually just spit that to the screen. And let's go ahead and do it 4 or 5 times here, just to take a look. So what I'm missing is this. Maybe I can get these both going at the same time here. Alright, so we've got the program there, actually, up top. So I'll compile it. Does it without complaint. We run it. And there are 5 definitely random looking numbers. Well, let's run it again. Let me actually run it up here this time. Alright. Note that those are the exact same very random looking numbers. This is the thing I'm saying where the computer can't truly divine random numbers, so there's a list hard-coded in the computer and it just pulls the first item off the list when you ask for a random number. If you ask for another one, it pulls the second item off the list. That's fine for games if you're like playing the game once, but if you play a game, each time you play the game, it's going to behave exactly the same way, right? So there's a function called srand, which means to seed. The term is to seed the random number generator. And all this is saying is instead of starting at the first position in the list, start at the nth position in the list. So I can actually do that. Let me go into my code here and let me say srand. And what I'll do now is we'll start at the 3,943rd position in that list. And then I compile it, and then I'll run it. Let me see, I'll run it up here as well. And we can see now these numbers are very different from these numbers. But if I run it again, I still get the same numbers. It's just now starting at the nearly 4,000th position, right? So what I need is a way to make this number change every time I play the game or run the program. And the one thing that changes all of the time is the current time. And there is a function called time. You pass in, I have it like this, pass in null. That's not important for the sake of the discussion. But what time returns is, and this is just a thing with Linux and Unix, is what is called the epoch, which is the number of seconds since the epoch, and the epoch is January 1st, 1970. So actually what I'm going to do, just to look at it, is I'm going to comment out all these random numbers, and I'll comment that out. That's not important for what I want to look at. Let's actually look at what this returns. That's the number of seconds that have elapsed since January 1st, 1970. If I run it again, you can see that I've run about 8 seconds there. If I do it quick enough, like here, I ran it twice in the same second, right? So this function is only changing once a second, obviously, as the seconds go by. So as long as I don't run my program more than once a second, this really will give me a different number. And if I do this right here, what it's going to do on line 7 is it's going to take this number, and that is where it will start in this list of random numbers. And so assuming I don't run my program more than once a second, I should start at a different point in that list, and then it'll give the appearance that every time I run the program, a whole new set of random numbers is appearing. Okay, so that's the rationale behind all of this. One thing to note, though, is this function should only be called once in your application, and typically a good place to do it is right after the program begins. Why only once? Well, some people end up calling it every time before they need a random number. They do something like this. And then we haven't talked about loops, but this could be, I'll just say loop 100 times. So if I do this stuff 100 times, well, 100 times it's going to reset the seed. And a loop in a computer program can go millions of times in a single second. So certainly for this case, 100 times it's going to loop in the same second, which means I'm going to set it to, say, this position 100 times down here. And 100 times I'm going to get the exact same random number. In fact, just drive the point home. Why the hell don't I just do it? All right, so this is the rookie error right here, is to do that. Put that in a loop. How about this? Let's take a look at what we're generating. All right, here we go. 10 random numbers. And you see they're all exactly the same because I'm resetting that seed just before I get a random number each time, and that seed doesn't change. So if I put it at the very beginning of the program and don't do it many times, then I get a different set of random numbers, and if I run it again, I get a different set of random numbers, and if I run it again, so on and so forth. All right? So that is what all this is. Initialize the random seed, do it only once at the beginning of the main function. There it is right there. I talked somewhat about this. I talked about this, but let's bring the rest of this together. Remember that the program wants you to have the computer generate a random number, so you generally stick that in a variable. So you create a variable to hold it. And then I have to give the computer its random number. Now, if the task was to guess the computer's random number between 0 and 4 billion, our work would be done. But the project wants you to generate a random number between 1 and 10. So, who remembers what the percent does? It does division, integer division. Remember, dividing integers, there's no floating point portion. That 19 divided by 10 is 1. 10 will go into 19 exactly one time. So that answer is 1. This answer with the percent is the remainder. 19 divided by 10, the remainder is 9. And again, if you're taking pictures or writing furiously, that's your prerogative, but let me remind you of the Todd A. Gibson patented note-taking strategy is just write the current time down if you're interested in it, and just play back the screen recording at that point, right? And this file, of course, will be uploaded with the screencast and so forth. All right. So it doesn't matter what this random number is. Let's start looking at numbers. 2, 3, 4, 5, 6. I'm going to say random number between right there. All right, so if I'm doing %5 for all of these, the remainder is equal to 0. Let me do this. The remainder is 1, the remainder is 2, the remainder is 3, 4, the remainder is 0, the remainder is 1, the remainder is 2, 3, 4, the remainder would be 0. So you see, if I do %5 here, I end up with numbers between 0 and 4 inclusive. So when we generate this random number right here, which is some astronomically huge number, whoops, not there, here, right? It doesn't matter what the number is. You know it's going to end up being between 0 and 5, or between 0 and 4 inclusive if I do %5 on it. So now we look at this. To generate the computer's random number, you do %10. That's going to give you a number between 0 and 9. Then you just add 1 to it. That gives you a number between 1 and 10. All right? Any questions on that? So that'll give you the computer's number. Then you just have to write the rest of the statements to ask the user for a guess and to do the comparison. Okay. Let me get rid of, I guess what I'll do is I'll leave this stuff. Let me leave that there. And I guess I can leave all this. I'll leave that as a big comment. Whoops. And then there's that. All right. So that takes us to what you need to do in class today, and it actually isn't due until Friday, but it shouldn't take too terribly long to do. Assignment 5. This is another one of those assignments where the project I'd like you to do individually, but the assignment, a lot of the assignments, particularly this one, I encourage you to get together with 1 or 3 people and work on it together. The motivation for me doing this assignment, I've only had it, I don't know, 3 or 4 semesters, not that long, is that this whole working at the command line is a bit of a confusing proposition if you haven't done it before. And people end up getting their stuff strewn all over the place, right? You've got lab directories and assignment directories, and you've got like 30 CPP files all sitting in your home directory. And it just looks like you went to a filing cabinet and just threw everything out. So this is to get you to do some practice working at the command line, organizing information. I've got this, ao5.tar. What you want to do is download it. And you need to get it to wherever you're working on Linux. So if you're using MOBA Xterm, you want to copy it up to Jaguar and deal with it on Jaguar. If you've got a Mac, it's a lot easier. If you're doing that Vagrant thing, just get it in that directory where you're running Vagrant. And I'm going to move out of my downloads. I'm going to get ao5.tar and I'm going to move it right here. There it is. And I give you a command. So tar just means tape archive. It's called a tape archive for historical reasons. Basically what it lets you do is bundle up files and directories together into a single file. Kind of a variation on zip files, only it doesn't compress like zip does. All right. This assignment is best done with 2 or 3 terminal windows open simultaneously. You can actually just copy that and paste it. This is the tar command, the tape archive command. I want to extract the archive. Like everything, all these commands, they work silently. So the V means be verbose, so you get a little bit of eye candy while the thing is running. And there we go. The output that you're seeing isn't tremendously important. All it's saying is that it's created an AO5 directory Inside of AO5, it's created a lab1, lab2 directory. It's created a file called lab3, a file called lab3.cpp, a directory called labs, and lab directories in there, and then some CPP files down deep inside. The X means that it's extracting. Again, it's not that important to note that. Let me see. Let me focus on what it says in the write-up here. All right. So what I want you to do is I want you to show me the commands that you do to fix this up. What I've tried to do, there's AO5, everything happens in there, CD, AO5, LS. And it's a little bit of a mess. I'll get into how it's a mess and how we can fix it in a minute. But as I said, I want you to open up another terminal window. I've got mine nicely separated, but I could literally just open another one of these and just run them side by side. I'll do it this way. All right. It's asking you to open up your editor, something called commands.bash. I suppose, strictly speaking, it doesn't matter what you call the file. This is where, in this file that I'm asking you to open, you're going to describe to me the steps that you do to fix up this mess of directories and files. Why is it a mess? It should be organized like this. You have a directory called labs. Whoops. You have a directory called... hang on. You have a directory called labs. Inside the labs directory is a lab01 directory and a lab02 directory. Inside of lab01 is lab01.cpp. Inside lab02 is lab02.cpp, and so on and so forth. Oops, that should have been indented there. I don't know why it isn't. These two should have been indented inside of these. I'll fix that once I'm done talking. So, in a second terminal window, investigate the hierarchy to determine what's wrong with it. And then it says in a third, yeah, I guess you could get away with two. As you type commands to fix it, also type in what you're doing in commands.bash. To correct the hierarchy, and I'll do some of this so you see what I'm talking about. Any empty files should be removed. Any non-empty but misnamed files should be renamed. And there may be redundant directories. Remove duplicate directories. Here's some useful commands. The one I'd like to point out in particular, a lot of these are straightforward. CD, where you currently are, get ls to see what's in the directory, move, which also can rename, remove, make directory, and remove directory. All right. File, I think, is interesting. Let's do file. Now, I have some help in that I have some syntax coloring here. That helps me know the blue ones are definitely directories. But let's say I didn't have the coloring. I could say file and then name something I'm staring at, and it'll tell me what it is. Okay. First thing is, I said remove anything that's empty. Note that this file command, we could open it up and see that, but it actually is a bit of a time waster. It shows 0 lines, 0 characters. Rather than doing that, just do file on it, and if it says it's empty, remove it. Remove lab03. All right, now I need to come down here. That was the first thing I did. I suppose the first thing I did was CD into AO5. Do an ls. How about file lab03.cpp? Whoops, I'm sorry. lab03cpp. There it is. All right, that's a program. I could take a quick look at it. There's a little comment saying what it is. It's the program code for lab03.cpp. So right away we see this one's misnamed. I need to rename it. lab03cpp to lab03.cpp. That's another command I did. Do another ls. File lab 3, oops, file lab 3. That one's empty. I should remove that one. Now I have a labs directory. That's where all this stuff should be, ls labs. Note that I've got lab 1 and 2 up here, and I've got a lab 2 inside of labs. So let me look at what's inside this lab 2. Okay, that one has lab2.cpp. Let me go down into labs. That one looks empty. So what I want to do is remove that directory. So what I did is I said cd into labs, and then I removed directory lab02. I'm going to go, there are a number of ways of doing this. I'll go back up. I need to move lab02 into the labs directory. I need to move lab01 into the labs directory. Move lab02 into labs. Move lab03 into, or excuse me, what was it? 1 and 2. And so on and so forth. You just have to keep moving this stuff around and get it all organized. Remove the dead stuff, remove the redundant stuff. All right? Any questions on what I'm asking? All right, so definitely feel free to get together with someone, and this is what gets turned in. You just turn in this list of, this file of commands that you typed in. Okay? All right, go ahead and have at it.